Now, let's take a closer look at the brilliance in our air-to-water system. The air-to-water technology lies within our R2 system. Our R2 system is designed for simultaneous heating and cooling with 2 refrigerant pipes, as opposed to the market conventional 3. With the 2-pipe system, the BC controller houses a liquid and a gas separator, allowing the outdoor unit to deliver a mixture of hot gas for heating and a liquid for cooling, both through the same pipe. The right amount of phases are delivered to each indoor unit with a LEV, short for linear expansion valve, depending on the individual requirement of either heating or cooling. Gas refrigerant is delivered to the indoor units in heating mode. If heating and cooling are required in the same system, the LEV switches the refrigerant flow. The gas refrigerant delivered to the indoor units in heating mode circulates back as condensed liquid refrigerant and is then delivered to the indoor units in cooling mode. Putting it simply, waste heat from heating operation is reused for cooling operation, and the more frequently cooling and heating simultaneous operation is carried out, the higher the energy-saving effect becomes. The reusing of waste heat is applied to air-to-water system. It utilizes waste heat from cooling for heating operation, which provides hot water. Air-to-water series consists of 2 types, a booster unit and a heat exchanger unit. Booster unit offers hot water to a maximum of 70 degrees Celsius. Heat exchanger unit offers 45 degrees Celsius in heating and down to 10 degrees Celsius in cooling. Both units are suitable for residences, office buildings, restaurants, or hotels, providing an optimum environment while benefiting from reduced running costs and less impact on our environment. Booster unit is connected to BC controller with refrigerant pipes and to the water tank with water pipes. There are 2 plate heat exchangers inside the unit where the refrigerant of R134A circulates. High-pressure R410A gas refrigerant is delivered from the BC controller. Low-pressure R134A liquid refrigerant circulating through the first heat exchanger is heat exchanged to become low-pressure gas refrigerant, and high-pressure R410A liquid refrigerant circulates back to the BC controller. To raise temperature, low-pressure R134A gas refrigerant is compressed by the compressor to become high-pressure gas refrigerant. Compared to the R410A refrigerant, R134A refrigerant requires less pressure to raise the temperature. To supply hot water, high-pressure R134A gas refrigerant is heat exchanged with the water entering the booster unit. The hot water circulates to heat the water inside the tank, which will be used for showers, floor heating, or panel heater, providing optimum air environment and hot water to a maximum of 70 degrees Celsius. Booster unit can be ideally suited for a wide range of applications, from office buildings, health clubs, hotels, to nursing homes. Next, let's take a closer look at air-to-water heat exchanger unit. Heat exchanger unit is connected to BC controller with refrigerant pipes and to the water tank with water pipes. Heat exchanger unit is not equipped with the compressor. To supply hot water, water entering the heat exchanger unit is heat exchanged with R410A refrigerant delivered from BC controller. Heat exchanger unit offers hot water to a maximum of 45 degrees Celsius and cold water down to 10 degrees Celsius. which is suitable in supplying water to fan coil units. Heat exchanger unit can also be used with our Y series, but there will not be a heat recovery operation.